to behavioral model meeting for January 5th, first one of the new year. I'll go ahead and display my screen. And I guess congratulations are in order to Marian. So congratulations, Marian.
Thanks, Christina.
You're welcome. You're welcome. Yep. And Marian, last time we were here and you weren't, it was before Christmas and we were talking and what were we talking about? Gerald was maybe going to look into getting some support internally for BMV2. And we had some people, we have some tests that we have that we're marking don't run in BMV2. And that's what I remember talking about. And then Intel was telling us about their P4 DPDK support. So these were kind of the notes from last time that we talked about. And oops, I need to admit some people in the lobby. I'm sorry. 1 second here. Okay, so let me see who just joined.
Hi, Christina.
Hey,
sorry,
good morning.
No morning.
Problem. No problem. I was just displaying the notes from last time before we left for Christmas. So yeah, so I think, did we have something yesterday in the community call that we were going to talk about today in the behavioral model meeting? I'll have to switch screens and stop sharing my screen. Does anyone recall what that was, or I can pull it up? I think it was about the private link service tunnel being injected into behavioral model.
Right. There was.
I think this conversation will continue on next Wednesday.
I missed that. Sorry, what?
I said that service tunnel private link conversation will continue next Wednesday. I don't think we should split the two meetings.
Sorry, Marian wants to present the service tunnel related code in the next Wednesday meeting, something like that. Yes, Marian?
Okay.
Yeah, are you having trouble hearing me?
Yeah, I was. I'm sorry. That's why I sounded hesitant.
Okay. I have two other items on my list that I would like to mention on this call.
Okay.
So number one is we raised the pull request for merging Dash API into SAI Master branch. It was approved by Microsoft and Intel, so whoever else wants to look at it and give some feedback,
yeah,
please do.
Thank you for
I'm sharing pull request.
Thank you for regenerating the API from the behavioral model, and I have just approved it this morning. Sorry for the delay, but thanks for doing that.
Yeah, and another thing, I have one request that I wanted to present.
Yeah, let me stop sharing. Go for it.
Yeah, it's more infrastructure related, but give you an overview of what it's doing. All right, you should see my screen. Can you see my screen?
Not yet.
Yeah, loading.
Okay, I can't see you. So let me try one more time.
There, I can see.
All right, so this is a small change to the SAI auto generation. Doesn't really change anything for the from the configuration point of view. It's adding a read-only attribute, and this is needed for SONiC CRM, which is using the SAI CRM APIs. So if we'll go to SAI, there is let me find it. SAI object, I guess. So there is an API to query how much resources are left in the ASIC per object type.
SAI object.
Okay, it's not here. All right, I'm talking about this API, SAI object type get availability. So this API allows you to see how many are left per object type, and in Dash we have new object types, of course, new entries like outbound routing entries, inbound routing entries, outbound CA to PA mappings, inbound PA validation entries, ACL rules, ACL groups, etc. So those tables can be their remaining size be queried with this API. So you pass the DPU switch ID that was generated during the SAI API initialization and creating a new switch instance, and you pass an object type of your interest, like for example, outbound route entry. And additionally, you can pass attributes, which are resource selectors, basically, which provide a more granular query to a specific, let's say, flavor of this resource. And an example of that would be all of the entries that are that have IP addresses as part of their key. So, for instance, the inbound routing entry or outbound routing entry will have the IP address in its key, which means that there may be in the implementation, may or may not, it doesn't really restrict you to information, but it may or may not have a separation for two different IP address families, or for instance, IPv6 address may consume more memory in that table. So when you pass this attribute and say, I want to know how many IPv4 entries I can still create of that type, or how many IPv6 entries I can create of that type, using this attribute, the API for availability query, passing it over here, it will give you a different result depending on the implementation. It could be the same, could be different, could be like a common memory pool, and then those two results will be dependent on one and another, and it means that it only gives you the amount of entries left, provided that no other types of entries will be created, or they can be separated and you know that this is your reserved number of entries. So all depending on the implementation, but this API allows you to look more closely into how much you have left. And what SONiC does is that it periodically queries all those object types provided, and now it will be able to query them per IP address family. And in case some of the resource availability gets lower than threshold, like let's say there's less than 10% of table left, it will raise an alarm in the database so that controller infra can read that and take the steps to mitigate that, like for example, allocating ENI on a different card or something like that. So this change is, let me just load that.
Marian, the watermark, is that possible? Is that configurable? or the 10% is
Oh,
specific?
it's SONiC. It's SONiC implementation, and yes, it is configurable. So you can look into the SONiC critical resource monitoring implementation. It has basically two configurable things. First one is polling frequency for those resource availabilities. I think it's something like 5 minutes. And then threshold is, it is also configurable.
Okay.
It's whatever you think is safe enough in your network. So you won't run out of resources.
So this is for the IP address family. Wouldn't we do this for all tables that we're defining?
It's for any table that has IP address as a key. So it includes, as I said, inbound routing, outbound routing, ACLs, CA to PA mappings, PA validation. I guess that's it. Maybe
awesome. Okay.
So
that's good.
so it will automatically add that. And other thing is like vendors are not necessarily required to implement that right away. SONiC infrastructure, if some availability is not implemented yet, you can just return not implemented, and it will just show it's not implemented in SONiC. So it's not like anything will be broken if you don't have it right away. So
does it include
small
connection tracking table as well?
Connection tracking will be included. It is contingent upon exposing connection tracking to SAI as a new object.
Right.
I'm working on that, but as soon as it will be available, this attribute will be added automatically to that table, to that object as well.
Got it.
Yeah, so this is the rule. Like whenever we have an IP address or IP prefix or IP prefix list as part of the key, this attribute will be added. And then it is at the discretion of implementation, how they want to represent those resources depending on the implementation. So yes, this is the change.
So
I will generate
one question is this,
as well.
this API is used by SONiC like just to monitor and display kind of accounting
and raise alarms.
I see. Okay. So if an implementation returns not implemented, you mentioned that it wouldn't cause any functionality issues, right? So it's just that the alarms would be disabled. What services would get disabled in that case?
No services will be disabled. Like CRM is still running, but alarm, in case you actually breach the threshold provided by the configuration, the controller won't see it. So that's the implication.
So I think we have the used count managed by SONiC, and then this is the available count, right? So and the default, like Marian said, is like 85%. So if that threshold exceeds, it will generate an alarm. But if the counter itself is not supported, then that particular resource is skipped.
Okay.
Yeah, so this one is, the GET API to look at the availability. Yeah.
Yes.
So,
yes.
And then all the other logic is all up at the NOS level to see that, okay, what's the use and then what to do, how often to monitor and what to do and so forth. So this is just what it is. But thank you so much. I think this is pretty good. So today, what I see that, Marian, that you have actually created a code to auto-generate the API, right? Now, the question here is that, the implementation part of the things which we today, when we do the testing and so forth, so can we, use this API on a BMV2 to validate the implementation, or at least, the workings of it?
It can be done. I think the question here is how urgent it is for BMV2, because there are different kinds of tests that we can do, like just tests isolated from SONiC, where you run traffic on BMV2, which is directly configured through SAI. And another thing that we want to do is to create BMV2 actually as a new target in SONiC. And in that case, having this API implementation actually done would be more preferable, because it would be used by SONiC in the BMV2 target. So I am not doing this implementation yet, but when we will finish the integration with SONiC, which is I think a plan not only from me but also from Microsoft side, to have as like another virtual switch. Then we will add an implementation to BMV2 SAI as well.
Oh, yeah, so let's put it this way, right? So because today we do the SAI implementation, which essentially is P4 runtime code, right? And then it's auto-generated. So any plans to auto-generate the code for this one so that we can at least do a SAI level testing?
Of course it will be. Yeah, it will be auto-generated. I just didn't put that there yet because, so there are two things. There is a size of the table, which is available for P4 runtime, and also the size. I think we can also get the number of entries that are already created for P4 runtime. So implementing this can be auto-generated as well.
Sounds good. Yeah, thank you so much. Appreciate it.
Yeah, we do want to make a virtual switch of SONiC to be able to run. So definitely like to do that.
Okay, so I'll just share a link to that.
Thank you. And you said this is for any table that has IP address, IP prefix, or what was the third one?
IP prefix list, like in case of
IP prefix list. Okay. As a key. Okay, thanks.
Where is these APIs? So these are SONiC APIs. I'm trying to figure out SAI APIs, and so they get approved within the SAI group, or do they get approved in this group, the Dash group?
Both, actually. So it was previously sitting on the side branch of SAI repo called Dash. And as I mentioned earlier, we have a pull request to now merge it to the master branch. Yeah, which also before that, I did a review of Dash APIs in the SAI community to explain like the purpose, what we're trying to solve and all that. So it is being approved on both sides.
Okay, good.
And if you look in the chat window, you can see the link to opencompute /SAI and then drop down and it's the Azure Dash GitHub. So there's both of them in there.
Now, will it continue to be two separate things, or will it just be merged into one thing?
Yeah, the goal is to merge it into one thing.
Yeah, okay, good.
Thank you. Did anyone else have a PR they wanted to cover in this session or discussion points for this time?
The other topic that we were discussing yesterday was the underlay routing, right? And here in Dash, we have the complex LPM routing with ENI, ID, etc. And then yesterday we discussed about the underlay routing and the two default routes that might be there for two towers. What are the thoughts on that? Do we need to implement another LPM for the two default routes, or there can be other ways to do it too, using ternary, etc. But I would like to just have the conversation here, get everybody's thoughts on that.
Mhm. Okay.
Prince, if you would like to, explain a little bit your thoughts on the underlay routing portion, um, it will help a little bit to start the conversation.
Sorry, Reshma, I was distracted, but if I hear you correctly, you are asking about the follow-up from yesterday's meeting,
Right.
yesterday's
Right.
discussion on the underlay.
Yes.
Mhm.
Yeah, I think I will clarify that in the HLD with few more details. But from what I understand, we don't need an LPM table, right? Because it's just the default route that we are going to get from the pair. So
the default route is learned via BGP.
yes, but the default route is learned via BGP, and of course the SONiC shall push that default route with say the next hop or the neighbor to the side, but the DPU can determine how they want to program it, because
Okay.
end of the day we are like, the expectation is not to do a proper lookup and match on a longest prefix and those things, right? It's basically how do you want to forward in the underlay, right? So there are only two cases that we need to consider. One is regular routing, like a default route that is pointing to one next hop. The other is a default route pointing to two next hops, right? The ECMP case. So if the SAI or the DPU, the implementation can take care of that two cases without any lookup, then I don't think we need a separate LPM resource allocated for this. The only routes that I think of is default route and some IP to me route. And I believe you have some ways to trap the IP to me packet, right? Without,
Right.
yeah. So then I think
That's a new
yeah.
word to me. What does IP to me mean?
So IP to me means the packets that are destined to the DPU. Like for example, the BGP packets, right? Of the peer is sending it.
Oh,
Yeah,
okay. Yeah.
So that also in the traditional switch world, we do like LPM lookups, right? Like even the IP to me routes are looked up in the LPM table, and then if based on the next hop, which is for IP to me, it's a CPU port, it gets trapped. But that also is not lookup that we would need to do in DPU. Yeah. I mean, does this make sense, or does anyone has any concern? Like,
Yeah. It is possible to implement it without having an extra LPM. If it is something very simple, just two entries and an exact match, and we can do it in different ways, and ternary cam, WCM, something like that.
So for the two next hops on the default route case, the implementation is free to choose some ECMP algorithm.
yes. So I think from the SONiC side, we will program the default route with, let's say, two next hops, right? Then yes, the implementation can do the hashing on one of that.
And we're free to choose the algorithm.
Do we have
I
an
know,
algorithm
like,
that we prefer, or are they free? Because they're
we
already
do
one defined.
we do the hashing on the 5 tuple, right? Like are you saying like
Yeah,
you can
yeah.
choose any 5 tuple, or
I think he's saying what's the hash? Like, do we need to define the hash, or are they just free to implement?
So what are the different hashing options available? Are there 1, 5, 10? I mean,
Oh, there's,
Well,
it's infinite. It's infinite. So if you want to define one, they should. If not,
Okay.
then it's fine.
I think like the simple thing to do is to assume that there was ECMP coming in. And that whatever port the packet came in on, we could just send the packet out on the same port and not even have to do hashing, right? If we're free to choose like how ECMP will work in this sort of 2-port default route case. Like, I mean, one of the reasons for ECMP is to like avoid like congestion on any one link. So like in that case, we would assume it's ECMP coming in as well as ECMP going out.
It's true.
Yeah, I think unless we have some strict requirements, that should work. Like sending the packet on the same port. And on the hash, we have the default hash defined by the SAI, right? So
That's what I was thinking. If you have one defined, why don't we just use it?
yeah. So I would say like will have to use that default value. Yeah.
is that in the Open Compute project where people can look at it, or?
Yeah, it's in the SAI
Okay.
definition. So
I mean, having a hash functionality is not a problem. There are plenty of them out there. I don't think SAI defines like, do you do 3 tuple, this is 5, whatever. Usually that's configurable on the router. In this case here, I'm not sure SAI defines API, maybe it does. But the bottom line is, why do we even need to compute a hash? I mean, computing hash is not, it's not free, right? We're doing dash, we're not doing routing here. So we need to keep it very simple, in my opinion.
So you're saying with ECMP, we don't even need to hash?
No, what I'm saying is we don't even need ECMP. We should define something simple like we talked about, where we just have 2 default routes. That's it. There's no ECMP, nothing. We just send it there and be done with it.
If you have 2 default routes, you got to send to one of them and you got to select one. I
It
think
doesn't
that's
mean
what
you
we're
need.
talking about.
Yeah, I know, but it doesn't mean you have a. That's the LPM part of it, not the whole ECMP with like 2 members and all those things, right?
no, it's not the LPM part, right? It's just choosing one egress port out of it, right? So it's not. So like we discussed, like the implementation doesn't need to worry about lookup or LPM. So it's basically the final forwarding. You'll have to choose one of it.
So how is this different? How is this different than any other normal route? So if you have 2 default routes, are we saying that these 2 default routes have the same cost?
Weight.
And if they have the same cost or
Yes.
same
Yeah,
weight,
yeah.
then you have to basically go ahead and then clearly, you are leaving it out onto the to routing to decide in terms of how it wants to do the hashing or whatever the algorithm that may be underneath to say that how am I going to choose one out of the 2 in order based on the packet that I'm or a flow that I'm going to pin on, and I'm going to pin that flow onto a single route, so to speak, right?
Mm-hmm.
So that's what I'm saying. Why would it be any different than it's a default route or a non-default route?
No, for the non-default or the route, then you'll have an LPM table required, right? So even the LPM table, what it deduces is your final next stops, right? So that is one thing that we can the implementation can take care. Like you don't need to do a lookup in the LPM table to find the underlay routing. So instead, based on the information provided to the SAI and SDK, it can determine how the packet forwarding has to, like, the packet to be sent out. So it's not exactly the same as in the traditional routing where you have a bunch of different. That's why I told in the beginning, like we don't have other routes that we are expecting in the scenario, right? It's just the default route.
So Prince, what you're talking about is that how someone is going to implement the lookup part of it, where the lookup is going to happen, whether it's in the LPM table or any other table, whether it can be either full match or complete match or whatever be the case, whether it can be hash table or it can be a LPM table. It's just the implementation issue of any ASIC who's developing the DPU, right?
Yeah.
So that's just the lookup part of it. But after the lookup, the decision to route should be the same, right? Irrespective of whether it was a default lookup or the LPM lookup, right?
Yeah. So in that uncle, I think it will be the same. Like if you have two next up, you'll have to pick up one out of that.
Right.
If you have one next up, you just need to identify the MAC and then forward to that.
Okay, thanks.
I mean, I think the original idea too could work. Just send it out the port it came in on, because it's already been hashed out the switch ports with a fairly sophisticated hash. So that probably work as good as anything. What you don't want is the implementation to prefer a port. Then that would not work.
Okay. Like always send on one port, right? Instead.
Yeah. You don't want that to happen because then you'd have to have the bandwidth. But they could either hash. I think they could either hash or they could do what somebody suggested and just send it out the same port because it's already been hashed already by the switch and sent to a particular port. So it's already pre-done. That hash has been done already. So you could do it that way too. I don't think there's anything wrong with that.
So we'll put both these things in the HLD so that it's clear, like the implementation is.
Yeah, and then there'd be a preference to what they do. What they should do is but they should be doing 5-tuple hash, right? That we don't have services that are not 5-tuple here. So there should be no 3-tuple thing or anything, but a 5-tuple hash or send it out the port it came in on. Just be consistent which one you do.
Mm-hmm. Makes sense, yeah.
Do we feel like we're closed on this question then, guys?
Yeah.
Actually, got a question on this. You could have multiple next off of the same port, right? So I'm not quite sure what the same port really means, I guess.
The same port here, what Gerald meant is the port on which you received the packet, the original packet, which you are trying to send it back. Right?
That's a DPU port are we talking about or the switch port we're talking about?
DPU.
The DPU
port. Okay.
Yeah.
I think what James might be saying is that if the BGP speaker from where we learn these routes, and we have two, that's why we think there are two sources for the default routes, right?
The two will be on two different ports, right?
Yes.
Yeah.
Sure. And in between, what if there are, if there are multiple hops away, then there are more paths, right? So there could be multiple next hops also. So, but in this case, if the design is such that the network design is such that there's only one next hop per BGP speaker, which is directly connected, then this should be okay, right?
So we always establish BGP between directly connected peers.
In our Azure implementation.
Yeah. We don't have multi-hop BGP sessions. So
well, also I think what she might be saying, I just want to kind of see if I understand it. Our implementation in Microsoft is everything is equal cost anyways. Right. Like we have a class network. So one path is not longer than the other ever, right? They're always the same, unless you have a transient, condition, but they're generally the same. I guess, what if somebody else did not have that kind of a network set up where everything is equal cost? Like maybe they're using Slingshot, whatever, some other network configuration, and then what would happen then? Would they both, you know, from a DPU's point of view, would they still both get, would the DPU get a default route from the both switches, even though that they may not be the same cost?
Right. If they're not the
That-
same cost, and also if there are multiple hops in between, then yeah, the next hops will vary.
There are two parts to this too. We've been talking about the port, but the DMAC, which is your next hop, doesn't have to be the same, right? I mean, that's based on your next hop itself.
Mhm.
I'm just saying that there are two parts to the equation here.
So is there a question we're answering specific to the Azure implementation or just in general? Is it James that's
No,
talking?
No, I think that this is not an Azure issue. We always have equal cost, right?
Okay.
It's a class network. But maybe other networks don't have equal costs. So I think they're just bringing up the point that does this just work in Microsoft and maybe not somewhere else because they're not equal costs to the destinations? And I don't know the answer to that, but it's a good thing to think about.
Mhm.
From a Microsoft point of view, it's not an issue. But it may be in a different.
But Gerald, in that case, the implementation, right? We provide all the details, like what is the default route, what are the next stops. So so those kinds of deployments may need to have the proper hashing.
Yeah.
Yeah. So
or LPM tables and stuff.
yeah, or LPM tables, correct. So
I think we could just note that in Azure in a class network, this is not really.
yeah.
If it's not using a class network, they may need for other companies, for enterprise, for example, if somebody wanted to use this technology in the enterprise, which I think they will, enterprise do not normally implement class networks, right? So they may have to do it differently.
Right, but in that case, the change is in the DPU implementation. So this not the change from the application side, because application side already provided all the details for the forwarding.
Mm-hmm.
Yeah.
Sorry, I'm just trying to keep up with the typing. Okay.
So I'm not too familiar with the class network or these, but if in the case of if it's not an equal cost network, then would the NIC or DPU IPU need to implement the actually proper LPM, because there would be different, I guess, sort of the hierarchy or LPM may need to be implemented. Is that is that correct?
Yeah, sounds correct. Then in the general case that would be needed, yes. But Microsoft's case, it could be simplified, it sounds like.
Yeah.
Here, the BGP speaker could also be in Tor layer or T1 layer, etc., right?
Right.
Yeah.
Okay.
I mean, I don't know how safe this is to recommend, but it sounds like if you're only planning to make a product that you can sell to Microsoft, you don't need an LPM lookup there.
Well,
no, I think we are providing.
Should not be the goal, right?
Yeah.
It should not be the goal to build products just for Microsoft.
Yeah.
I'm not.
That was tongue in cheek, I think.
I'm not making recommendations. I'm just saying if push came to shove for an implementer.
Yeah. Yeah. Does that answer the question pretty well then? Was it James that was asking?
Yeah, it does for me. Yes.
Okay, good. Okay, so we're 44 minutes in. Anyone else have something for today? Okay, and Gerald, I'll talk with you offline later. And thank you, Marian, for coming back and presenting your PRs. Thank you for that. And thanks, Reshma, for doing the approval there. And I can give time back unless you guys have anything else.
Yeah, I
So-
would just like encourage people that the discussion yesterday was really good because it introduced the two new services, Private Link and Service Tunnel. Before next week, if people have questions from that, because there was some questions, but not a lot of questions. If people have questions, maybe they can send them in before next week so that Prince will update, based on yesterday's questions. But if you want to have more questions, it'd be really good that we could make sure that everybody has the same understanding of those two services.
Mm-hmm.
And the other thing, I have a question for Prince, if he's still on. Are you still on, Prince? So I was told, and I just want to validate that VNet to VNet, the APIs that were created for that actually are sufficient for VNet peering and global VNet peering.
Yes.
And because of that, do we have any description in HLD just at least describing, okay, so if they're sufficient, what were those? Like what is it doing? So that the community actually knows, what that means, because, especially global VNet peering, I doubt if anybody on this call even knows how that works. Is there any description? Do we have a document?
So generally in those cases are handled in a generic way. I think Christina's SDN features and packet transfer, that document has details on what is global peering and and VNet to VNet peer. Yeah, so those things, right? But
so we think we have it.
We have it as a understanding there, but in the HLD, it's generic. Like in the schema, if you look, like you look up a particular route, right? In for an ENI, and your destination is either the same VNet or the another VNet. It's generic. So if it is another VNet, it means it's a peering scenario. But that part I didn't capture explicitly. Like if it is a different VNet, that means it's going to a different. Like it's part of a peering configuration. Maybe I can add few cases.
Yeah,
there.
just a few cases, just so that people know that, because we always talk about all the services, and it seems like we did 3 services, and people are like, oh, we're still under per service. So actually, we did 3, and then you just So if we could just make enough mention of so people tick the box. Oh yeah, we got that, we got that, we got that. Now you're adding 2 new services, which is the service tunnel and private link, and tick off that and tick off that. So then what's left? And I think it's SLB is the big one.
I think I got it. I think today it's like the same schema will work for all the 3, so we didn't capture it explicitly. So
It's just
I think
words.
Sure. I'll add that. I think for the global VNet peering, it's mainly the IPv6 underlay. So that's the key thing, and that's the differentiator. But
I'm just throwing up a couple of links here while we're talking, if anyone's curious.
No, that is great. Thanks a lot, Christina, for doing this. And thank you for bringing this question, because so far, I was thinking that, okay, we were doing VNet to VNet, and I'm just trying to really figure out what was the difference between VNet to VNet and VNet peering. I'm sure other people know it, but I wasn't really sure about the exact differences between the two. And now we have a third one, which is global peering. So VNet global peering. So it will be great to just have something very small just to say, okay, what are these and what are the differences among all 3? That way we will know, okay, well, we already have done all of those things, but it's just that now we know the differences.
Have the question. Also, a lot of people have the question because they want to make sure that they're testing properly. If you're going to do global VNet peering, they want to know that, that's a IPv6 overlay. Then they're going to put some, more emphasis on that. But, it's because we always say these 7 services, which I don't think are really 7, but we always used to say that. We have ticked about 5 of them off right now that are mostly defined. The last 2 Prince just introduced this week, but, over the next couple of weeks, should be able to finish that. And then it's just a matter of for the community to know. So how many else are, how much more is coming, at least in the initial run? And I know SLB, what some people call, I think they call it
Fast path.
Fast path.
Yeah, fast path is there.
Yeah.
So, and that's mostly there. It's just that I know that there's some port mappings that haven't been defined in the APIs for that. So, but I think that's the big major one left, isn't it? Is there another one after that? I don't know.
Cryptography.
Yeah, that's, I'm just saying of the base original services. I think that finishes it.
I think what's a challenge for me too, guys, is, we have the descriptions, like these documents that I'm pulling up here. It tells you what it is, but this does not tell us as technical contributors what is the difference in the packet transformation that's going to happen. That's what I don't have. Like, this is great telling us what it is, but at our level, when we're trying to say, okay, we need to pop this header, we need to change this piece, and we need to change this end cap and blah, blah, blah. That's what's not in these documents, Gerald and Prince.
I thought that was in the transformation document. Didn't it show all the headers?
In the transformation document, you should have, Christian. If not, I think we should have that clarified.
Yeah.
So in the packet transfer,
she does have it. It's not called that anymore.
It's there, but it's without an appliance in the path, right? It's at the very, very bottom.
It's at the bottom, but it shows all the end caps.
What's that?
It shows all the end caps for between VNet and VNet global peering and stuff.
Check. So here's load balancer. Here's VM to VM. Private link is right here. So you would have to know how to read this, starting from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay, but at least they're there. Keep going down. Yep. Do we have service tunnel here?
Right
here. We have service tunnel, and do we have global VNet peering or VNet peering, or
that would be up. That would be upper. That would be up. And let me grab that.
I don't think there's anything.
We don't have the peering. No, I don't have the peering. That wasn't
because it's really this. Only one has IPv6 headers, and one, these ones don't. And the VNet
and that's
peering,
what I don't have.
Like VNet peering is this exactly, because there is no. It's an SDN principle. It has the data path doesn't even know there's VNet peering going on.
Correct. That's right. So whether it is the same VNet or different VNet, it's pretty much the same for the data path.
And I think we could even put that right in this document here, that VNet to VNet peering is seen below. VNet to VNet is seen below. VNet peering is identical. No data path changes, and VNet global peering uses IPv6 as the tunnel, and it's still the same tunnel format. It's just IPv6, right?
Yeah.
And we could put those comments in there for one.
Yeah.
We should put a diagram here. Like, none of these are all showing like kind of IPv4.
Yep.
I think that's something that maybe we're going to have a version that shows an IPv6.
Yep. Yeah, I have questions into Niraj and Pranjal to ask about that, but yeah, and I can easily add that comment that you just mentioned. I can pop that in here, no problem. But this is what I have, and I'm just saying, as an overall description, this is cool. We can talk about what it is, but when we're talking about the transformations, that's what our people need to know.
So what kind of additional information other than this diagram do we need? Do we need like verbal descriptions of how to read this, or like what's the?
Some verbal description would be good. Like, for example, intra VNet, this is how the NCAP will be, and VNet to VNet and VNet peering are similar in terms of the changes needed in the NCAP as the packet goes out. Something like that would be useful.
Yeah. And then
I think we can do that. I was thinking more the technical side. Are we missing? Does the implementers need to know anything else than what we just said? Because those NCAPs seem to be drawn, and we're going to put a little bit more verbal stuff in there for the first 3 services. And does anybody need anything in addition to that? Is the question.
I just want to, so far as you were doing this VNet and VNet to VNet and VNet peering, it was more of a synchronous, right? You would see that, okay, both sides are essentially doing the same thing. Now, as we are going towards services, such as, shared services we talked about, for which we have private links and service tunnels, is this also symmetric? In other words, are we expecting the services to be running on the DPUs as well? And if it is, then we need to really tell, yeah, this is what it is expected. Otherwise, it's just a service which knows that how it's going to get the packet and how it's going to decapsulate it and so forth, right?
I don't think I got the question.
Symmetric versus asymmetric, or?
Yeah, symmetric in the sense that, hey, I mean, is
Bump in the
because
wall.
remember we said that, okay, there is a shared service, right? And then the shared service can be storage or any database or whatever be the case, which essentially is advertising or running it on a public IP address. So now your VNet is communicating to that shared service. Are we saying
Yes.
that shared service is also running on a DPU? Is it expected out of this one that, okay,
No.
here now we
No,
have both sides,
no.
right?
No.
So it's not symmetric in the sense that, okay, it's just the VNet who is communicating to it and so forth, right? So, right?
So, yeah, so the
We don't-
packet flow would be the oh, sorry, go ahead, Sarah.
Yeah, the one thing, keep in mind that even with VNet to VNet, maybe one VM is enabled with Sirius. Doesn't mean the other side's enabled with
Right.
Sirius. You don't ever have that kind of symmetry. You can't be guaranteed that there's a DPU anywhere else. You might be the only DPU enabled VM in the entire network for all it cares. So it's the same thing with storage. I mean, maybe it has a DPU someday. In fact, we plan on it, but today it doesn't.
Yeah.
And it doesn't matter, right? Like these all have the same encapsulations, whether they're DPU or not.
Yeah, I think the key point is the VM that is the source, like where the DPU is servicing, right? The VM sends the packet to the DPU and DPU sends it to this shared service like storage. The return path also comes through this DPU for this VM. So the VM is the one that is serviced by the DPU and not like it's not guaranteed that other side also has a DPU.
That's right. And then yesterday you said that when you establish that service, it's always bidirectional anyways. You establish both flows. We don't have such a thing as a single flow, like a single directed flow. It's always bidirectional. But if you have questions like this, that's what I was saying, if you guys have questions or you're not sure about how those two services work, write them down and get them in before next week, and then maybe Prince can be prepared to answer some of them. Because I'm sure people have questions for sure. But yesterday,
yeah, I think I think we can. I don't know where, because the service tunnel PR is merged, so maybe we can add it into the GitHub like issue or those places you can post questions. So
yeah. Okay, that sounds good.
Good. So it's 10:57. Is there anything else for today, guys? My team here. Then I'm gonna go ahead and stop the recording, and you guys have a good rest of the day. And I'll actually send notes on this meeting and take care of my action items. So thank you for coming, and again, congratulations, Marian.
Yeah, great.